Hello everyone, I'm Riddhi Suteri and today we will be discussing this question, that is find the town judge. So let's look upon this problem description. Obviously we can pause the video and read this description. Since I've already read the description, so I'll give you the brief information about this description. So it says that there is a town and there are n people living into it that are labeled from 1 to n, and there could be a possibility that the town might have a town judge. And for a person to be a town judge, everybody in the town, obviously except the town judge, should trust him, and nobody the town judge should trust nobody. Also, additionally, we are given with this additional trust array. Trust array is basically a array of pairs wherein each pair signify that, suppose a pair is ai comma bi, wherein ai is trusting bi, so each pair signifies that. So we have given with this trust array as well. So if we are able to locate the town judge, we have to return its label. Suppose in this sample example, b1 could be a town judge, so we have to return bi. And if we are not able to identify the town judge, or if it doesn't exist, we have to return -1 for that. So I hope the problem statement makes sense now. Let me also explain this via help of this diagram that I have made previously. Okay, so I have taken this sample example wherein the town has 3 people that are labeled from 1 to 3. And in the first example, you can see that I have made this trust array. So in this trust array, you can see that 1 comma 3 signifies 1 is trusting 3. So I can write this relation here, 1 is trusting 3. Similarly, 2 comma 3 means 2 is trusting 3. And lastly, this means 3 is trusting 1. Clearly, you can see that 1 is also trusting somebody, 2 is also trusting somebody, 3 is also trusting somebody. So there is a clear case wherein we are not able to find the town judge, or simply the town judge does not exist. So we can return -1 for this case, right? So let's look for the second case that I've mentioned here. Okay, so in the second case, 1 comma 3 means 1 is trusting 3. Okay, sorry about my handwriting, because I'm writing with the help of mouse, so it is quite difficult with it. So let's get back to the question. Yeah, 2 comma 3 means 2 is trusting 3. 2 comma 1 means 2 is also trusting 1. Okay, no problem. 1 comma 2 means 1 is also trusting 2. Great. So yeah, it's 2. So as you can clearly see that it is a clear case of 3 being the town judge, because 1 is also trusting 3, 2 is also trusting 3. By the way, 1 is also trusting 2 and 2 is also trusting 1, but that's not of a concern, because we are only here to judge that is 3 being judged by, is 3 being trusted by everyone, and also that is 3 not trusting anybody. So it is clear that case, so we can simply return 3 for this example. Okay, so I think the problem statement should be clear by now. Now let's think that how we can solve this problem. So one simple and very intuitive solution to this could be, since we have to map these relations, I mean we have to analyze this relation, that who is trusting whom and who is being trusted by whom. So what we can do is we can simply make use of matrices or 2D arrays, and we can prepare a 2 cross n plus 1 matrix, because we are taking the rows as first rows as the trusting wala part and the second row for the trusted wala part, and for the columns we have took the number of people, the labels of people alongside the columns, right? Now what we are planning to do here is, we are planning to, as we are skim through this, as we traverse through this array, trust array, we are planning to map these relations here. And once we have completed this trust array, we are planning to traverse this 2D array, and while traversing this 2D array, we will look for the relations that in which for which people we can find that trusting wala part is 0 and being trusted wala part is exactly n minus 1. Why n minus 1? Because since there are n persons, so excluding the judge would be n minus 1 person that should be trusting the person in order to be a town judge. So let's map these value into this, and let's see if we are able to find the find who is the town judge or not with this example. So let's take the blue pen. So 1 comma 3 means that 1 is trusting 3. So also one more thing that I forgot to tell, that in all these initial values will be 0, and as we find a relation we will increment the current value. That is, we will if there is 0, if we find a relation here, we will increment this value to 1, right? So in this case, suppose 1 comma 3 is present, so what we will do is, for the trusting wala part, we will remove 0 and we will increment it by 1. Similarly, 3 is being trusted, so we'll go to 3 and we will increment the counter here. Similarly, now we move on to the next pair that says 2 comma 3. So we will reach at 2, we will mark 1 here, and we will go at 3, and since there is 1 already present, so we'll make it 2, right? Then we move on to the next pair that is 2 comma 1. So we'll mark this 2 and we'll mark this as 2. Sorry. Yeah, so we have to mark this here, right? And yeah, and then we will move on to 1 comma 2. So 1, since it's already present, we will make it 2, and in this part we will make it 1. So with this we have traversed all these pairs, and now when we traverse through this 2D matrix, we can clearly see that we have to look the situation, we have to find the situation wherein this trusting should be 0 and trusted wala part should be exactly n minus 1 times. Since there are 3 number of people, so this signifies, or this matches our requirement, and hence we can clearly return its label, that is its index, and 3 would be our answer as discussed with this, right? So let me quickly write this code. I'll fast forward the code because I don't want the video to be that much lengthy. So we can see that we have created a relations array wherein we have created it of size 2 comma n plus 1, because 2 we are creating for the rows, as I've already told you with this example, one for the trusting and one for the trusted. And for the columns we have taken n plus 1 because we want the nth index to be in the matrix, and if we create it of size n plus 1, the last index would be n. Similarly, now what we are doing is, in this loop we are traversing through the pairs array, that is this trust array, and inside this what we are doing is, we are going into the relations 0th index, I would say 0th row, and then at this row we are now going at the index of the element that we have found. Let me explain why. So we will point out this 1 and we will reach to the relations first index, first column I would say, because the second bracket represents the column. We will go at its first column, and for the 0th row, and we will mark 1 here. I mean, we will increment the value here. Similarly, likewise we will go upon its first row and we will mark the we will reach its third column and we will mark, or we will increment the value here. So I hope this is clear by now. So after the end of this loop, we will be doing is, we will be successfully marking all of these relations, and once we have marked all of these relations successfully, what we have to do is, we simply have to traverse through this 2D matrix, and with this, inside this matrix we have to look for this particular situation wherein its 0th row, that is for the trusting wala part, should be containing 0, as I've told you with this example, because the judge should not trust anybody, and the trusted wala part, that is its first row, should have exactly n-1 number of people. I mean, should have n-1 relations. Once we have found this relation, we simply have to return its index, because as I've already told you that we have mapped this indexes with the people's label, right, with the people label. So yeah, after running through this loop, if we have not found or if we have not encountered this return statement, it simply means that there is not any valid town judge here. So we can clearly return -1 after that. Also, we have also handled some edge cases here as well. So one simple case would be if there is only one people living in the town. So anyways, it will be the town judge. And also if there are no relations present for us, that means we are unable to find that who is the town judge or not. So we can clearly represents -1 for that. So let's test this code. Yeah, so you can see that it is running fine here. And once we submit this, yeah, it got accepted. So yeah, this was the video. If you liked the explanation, or if you want to encourage me, you can clearly consider subscribing to my channel, and you can like the video as well. So thank you everyone.